റിഹേഴ്സല് ഇപ്പം ഒരു 20 പാർട്ടിസിപ്പൻസേ ഉള്ളൂ. നമുക്ക് ഇച്ചിരി നേരം ഒന്ന് വെയിറ്റ് ചെയ്യാം. Okay, participants, please wait for 5 more minutes so that others can also join. So good afternoon, one and all. We welcome all to the final day of a city training and learning online activity program on emerging trends in electric vehicle ecosystem, power electronics, AI, and sustainable mobility. Today we have 3 sessions, and after that there will be an evaluation, and we can give the feedback. Both are done in the Aicte-Atal portal, the one which you have logged in and registered. Okay. So then from 7:30 to 8 p.m. you have to rejoin, and then there will be a validatory function and closing remarks. So today is this is the agenda for today. So we have now we have a session on EV simulation tools and digital twin application by Dr. Riyaz A. Rahman from Coral Technologies Private Limited, Bangalore. He is dealing with the Madhvat products. So Riyaz sir is here.
Good afternoon, all. Good afternoon.
So for the yes, sir, you are audible.
Yeah.
So for the official introduction of officially introducing Dr. Riyaz, I invite IEEE student branch chair, Devanshi.
Thank you, ma'am.
Okay.
We are honored to welcome Dr. Riyaz A. Rahman, Senior Application Engineer at Coral Technologies Private Limited, Bangalore, as today's resource person. Dr. Riyaz has an extensive academic and industry background spanning nearly 2 decades. He is currently associated with Coral Technologies, where he works closely with MathWorks products, contributing to advanced applications and technology solutions. Prior to this role, Dr. Riaz served as an associate professor at Reva University, Bangalore, and earlier as associate professor and joint director of strategic communication at ACE College of Engineering, Thiruvananthapuram, where he was actively involved in budget management, skill development, and strategic initiatives. He also served for several years as assistant professor at ACE College of Engineering and at Lourdes Mata College of Science and Technology, Thiruvananthapuram, where he held key responsibilities, including Chief Superintendent of University Examinations, ISO Internal Auditor, and organizer of national conferences and seminars. With with over 19 years of experience in teaching, training, research, and academic leadership, Dr. Riaz has guided numerous students, coordinated career guidance and placement activities, and played an instrumental role in setting up advanced laboratories and digital initiatives. His areas of expertise include instrumentation, process control, team leadership, strategic communication, and skill development. He also holds professional training and certifications in instrumentation and process control. Today, Dr. Riaz brings with him a unique blend of academic excellence and industry insight, which will be immensely valuable for our audience. Let us extend a warm welcome to Dr. Riaz A. Rahman. Over to you, sir.
Thank you. Thanks a lot for the introduction. So today, the agenda for today's session will be to introduce all of you to the EV tools, which are like very much necessary by if you're working in the electrification area. So uh, the whole idea is that I know that there were many eminent persons who have taken on different areas in electrifications for the past few days. And post the session also we have extensive sessions in battery management system and grid areas where electrifications are like EV vehicles are very extensively used. So the area which I'll be touching is, since I am working on MATLAB, so I'll be touching on the products or the tools which is actually necessary to work with EV from the very basics to the advanced level, where there are many set of applications that are available in MathWorks products in MATLAB to work with electric vehicle technologies in a seamlessly easy way. So with that note, I'll start the press. So I'll start with a very basic presentation, then to take you all to the MATLAB tool. I hope every faculty here would have worked with MATLAB during their academics or during the research activities, and most of them will be aware of the Simulink and Simscape workflows which is there in MATLAB. So now the recent update in MATLAB is that MATLAB has introduced MATLAB Copilot in the offline version, and the chat playground in the online version. So both these are very helpful in understanding or finding the resources where you can easily use MATLAB. And with this Sure. And with this note, I'll take you to the basic presentations which I have curated for today's session. So let me present my screen. Please confirm if my screen is visible to all.
Yes, sir. Yes, sir. Yes, sir.
Yeah.
Your screen is visible.
Sorry. So I'm not going into too depth of this presentation because the slide will have this is about there are about 85 slides in this. So I'll take you to the important part of this presentation. Just a second. Hope this is visible now.
Yes, sir, it is visible, but it will be more convenient if you. Uh, yeah,
Yeah.
it's now okay.
Okay. Fine. Fine. So coming back to, so we know that from ever's like electrification is like the talk of the present era, where we have all this disruptive vehicle gaining the markets for as acceptance. Name every company is moving into electric vehicle technology. So coming to the main part of this session. So this is a overall EV architecture which we every electrical engineers or mechanical engineers will be working. So we have your grid and then the vehicle body and the parts which is associated with the vehicle body for electric vehicle. So you know that from the grid you will be charging and there should be a converter. So an AC to DC converter is there, and the energy will be stored in the battery pack, and from there to different parts of the motor or the vehicle you are giving charges to different parts. So we need to have DC to AC converter for running the motor, as well as DC to DC converters, or like maybe a buck converter or SEPIC converters, or different kind of converters to load the electronic parts of the electric vehicle. So how to implement this entire thing in MATLAB is what we need to understand. So for that, we need to have the basic understanding of the different tools that can be used while modeling this electric vehicle. Name it the vehicle body, the drive line, the powertrain, the converter part or the power electronics part, the battery management part, uh, name or the motor modeling. Name any area, or there are many motors that is available. So name any area. All these areas can be integrated together with MATLAB. So with this note, I'll show you just a basic model of MATLAB. So this particular model, I hope this is visible.
Yes, sir, it's
Yeah,
visible.
yeah, fine, thanks. So this is a vehicle model for a four-wheel drive, which is created in MATLAB Simscape. So why it is Simscape means you can see the
Yes,
different
sir.
color. Sorry,
Excuse me, sir. Sir, can you present it in full screen mode?
I can enlarge this because it is in MATLAB. So
Oh, okay. No problem. Then
yeah.
that's fine.
So starting from, so as I told, this particular model is created or developed in MATLAB Simscape environment. So Simscape environment is a platform which is built over Simulink. The difference of Simulink and Simscape is Simulink is a model-based design platform, whereas Simscape is a physical modeling platform.
Sir,
So
actually, we can see the slides soon.
only slides
Yes, sir.
now,
Yeah.
not this screen.
No. It's not the MATLAB screen.
Oh, sorry. Let me have a
Sir,
check.
you can present the screen
One second.
while
One second.
you are presenting.
Let me check. One second. Screen. So I'm taking the entire screen. Okay. So
Yeah, it's now it's
now
visible.
it's okay.
Yeah,
Fine.
yes.
So as I told, this is a Simscape environment, and the difference is that Simulink between Simulink and Simscape is that Simulink is practically a model-based design where you have mathematical equations and you can convert that to the block forms and analyze the end data. Whereas Simscape is also known as physical modeling. Probably everyone might know that. And how to analyze or understand the difference is based on the color coding, which you can see. So almost all the mechanical models or the body ins or tools which is used in Simscape will be in like light green in color, and the vehicle body this as such we can see it is in black in color, and if you are taking any thermal products, it will be orange, and if it is electrical, it will be like blue, light blue in color. So you will have to understand the working environment between Simulink and Simscape. And this is the four-wheel drive mode of a vehicle, and how to work with this or start developing this is to understand the tools by using the library browser. So if I click onto the library browser and then I go to Simscape, so I'll enlarge the screen. So I'll go to Simscape, and then if you want to develop your vehicle body, then there is the inbuilt like MATLAB block for vehicle body, as well as if you want to create your tires, there are three different kind of tires. Normally in industry, when we work with electric vehicles, they for simulations we normally I what I have seen is they normally take for magic formula, tire magic formula, and then others are like basic parameters where it's a simple tire model. So this can be connected with the vehicle body, which is as shown in this block diagram. So first we will take the vehicle body. So this is the vehicle body, and you can add image to this. That's why you can see this as a subsystem, and then you can connect all the wheels to this. So you can see from this there are all the three tires which has been placed. So as an when based upon your application, you can select your tire system, and this is like left and front and back, front and rear, left and right tires which has been placed. And also this is the differential, front differential and rear differential given to this, and this is the inertia, moment of inertia, the gearbox, and also the engine. So all these parts can be like taken from the Simscape environment, this environment. And if you want to have gears, you can have different kinds of gears from the toolboxes. Then the transmission line, if you want like 4 speed, 6 speed, 7 speed, 8 speed, based upon all these are based upon your applications, you can take all the necessary toolbox, fit into the Simscape environment, and like work with this. So this is how you create a basic understanding when you start working with EV motor. So then when you are going to the electrical part where uh, you have to create the Simscape model of any power converters, then you need to use specialized power system toolbox. So here all the power electronics components will be used. Like if you want a PWM generator, then if you want like signal sources, then if you are working with grids, then power grid toolboxes, as well as the components, passive components, all the passive components. So all specialized toolboxes can be, or from electrical toolboxes can be used from specialized power system, like sub criteria or sub area, and you can also use the controls, the machines, whichever kind of machines you want to use. So this is how you need to access the toolboxes from the library function, because at the initial stage everyone will not be available or aware, will not have the idea where this toolboxes or what will be the nomenclature of the toolboxes available in MATLAB. So the easy way is to access the library browser, uh, maximize the screen, go to the Simscape foundation library, Simscape library. Then inside all the Simscape library, you will be able to access all the components which is required to develop the vehicle. Now there is additional toolbox set which is available in MATLAB, which is related to the vehicle dynamics. So it is known as the vehicle dynamics block set. So you can see the vehicle dynamic block set, which consists of the powertrain block, sensors, steering, suspension, vehicle body, vehicle scenarios. So this will be used mostly by, if you are working in an interdisciplinary platform where mechanical engineers are there, uh, electrical engineers are there, electronics engineers are there. So it is applicable to all these domain where you can fit into the vehicle dynamic block set for powertrain or sensors and different sensors and vehicle body, and putting all these together will create a vehicle structure with all the necessary components. So coming back to the presentation, uh, so initially we'll start with physical. What I have shown is this is model-based design of a DC motor. So this is a MATLAB simulating model of DC motor, and which is governed by basic two equations. This is the first equation starting with the voltage, and then with the angular velocity of the motor, and these two equations are used to develop the simulating model. So this was the initial stage where when there was no SimScape facility available in MATLAB, so everyone was working with simulating environment. So every component's math equations was actually required to model the entire simulating structure uh, of every, maybe every component. Then then once the physical modeling came into place, so the entire blocks can be reduced into physical modeling. So this shows the DC motor of model of a or SimScape model of a DC motor, where we have the voltage source, the electrical part, the electromechanical part, and the mechanical part. And from there, the control of DC motor through a discrete PID controller, where you take the feedback from the plan model, and the control parameters are being given, and uh, you can control the motor through the feedback signal. So once it is done, so once we are good with the motor modeling, then the second part, because any vehicle will have different kinds of motor you can use. I have shown an example of DC motor. We have permanent magnet synchronous motor, BLDC motor, different kinds of motors are available in electric vehicle technology. So based upon your area of expertise, you can work with those motors as well. Then coming to the converters, there are different converters as I mentioned, like DC to DC, AC to DC, and DC to AC converters. So the next thing we'll be working will be how to model a converter. So here I have taken, this is a hardware interface we have, which has been taken with respect to a headlight. As we know that the headlight of the vehicle, as per the latest technology, it can it can function in an auto mode, where based upon the light intensity, the brightness, or the atmospheric light intensity, the brightness of the headlight can change accordingly. So maybe when it comes to say 6 p.m., the vehicle, or under dark conditions, the lights will automatically turn on. So this is a hardware interface where you can actually experience or experiment with a hardware board of an light, which can directly be fitted with MATLAB, and you can download the entire program through HTL coder or embedded C coder to the microcontroller which is used in your hardware board. So this is a circuit diagram, and this is a SimScape model for a SEPIC converter which is being used, a DC to DC SEPIC converter. The first idea is to model the parameters of all the passive components which is available in the SEPIC converter, then to provide the gating pulse to the power electronic switch, and analyze the output uh, based on the functionality of the SEPIC converter. And once it is done, the next parameter is to understand the thermal part of this. So I'll show that. So I'm going a little faster because of the, like, for the interest of the time. Yeah. So once you have analyzed with the basic DC to DC SEPI converter, the next parameter is to understand the thermal aspect while turning on the power electronic switches. So for that we use a thermal component, as I told. The ambient temperature can be measured from this circuit by using the thermal part. And as you can see in Simulink, the thermal components are all shown with orange in color, and the heat flow is analyzed. And then through MATLAB, we are visualizing or understanding what is the current and voltage based upon the thermal aspect for the same SEPI converter. So this is a video presentation. And once the thermal aspect is analyzed, then we will be taking the feedback control part. So the voltage, we'll be using a DC to DC SEPI converter voltage mode control, where we are taking the voltage feedback to uh, the and the data is taken and the error is classified, like identified, and based upon that the gate has to be triggered. So this is the block diagram which is used, or block which is used to give the feedback of the voltage and compare with the reference voltage to get the PWM pulse. So this is the PID tuner, control tuner, which is used in MATLAB. So I hope everyone has worked with while we are studying like control system as well. And from this we can analyze the tuned values of P, I, and D, and also the rise time, settling time, overshoot, peak value, gain margin, phase margin, and the stability analysis. Now, for this a video presentation, I will skip this. So once our DC to DC converter analysis is completed, then the next step is to like analyze this in the real time. So the MATLAB has the provision to connect the SimScape environment directly to the hardware, and how to generate it, or to connect it with hardware. If you have embedded software like C, C++, all these embedded coders, and if you are working with any other like FPGA boards, then we have VHDL or HDL coders, and this has to be invoked initially. Then connect your hardware to MATLAB through your serial port, and then once you run the program, automatically the circuit or the SimScape model will be converted into equivalent C or C++ or like HDL code, and it will be dumped into your microcontroller or FPGA boards. And by changing the values, you can analyze, understand the brightness level, the intensity level, whether you have to like the voltage level. All these parameters can be analyzed directly in hardware, through hardware. So that is a demo which is shown here. So this is the hardware support package which is available to download free of cost once you have a licensed MATLAB with you. So next is the battery pack and the battery management system. Of course, like in the next session, our resource person will be handling about the battery management and battery pack system to a deeper way. But what I can show in MATLAB, the best way to analyze the battery management system is go to MATLAB app or the main window, and there is an app called Battery Builder. So the advantage of using certain apps in MATLAB is that you can, like, if you want to work with your battery, rather than like developing your own battery for right from the circuit, then the thermal part, the all this, instead of that, MATLAB has the provision through this battery builder that you can develop your own battery pack. So this is the battery builder app, which is comes as an add-on with the license. So to start, how to start with the battery builder is that you need to start by developing a single cell. So by clicking to the cell icon, you can see a new interface where all the directions are mentioned, X, Y, and Z direction. So you can stack your cell in any of the direction. So to do that initially, like for example, I'm saying I am renaming it as uh, new cell for Christ College of Engineering, and I can either stack this in y-axis or I can stack this in x-axis. So let me take it as y-axis, and here you can specify the geometry of your cell. There are three geometries basically available in MATLAB. One is cylindrical, second is pouch, and third is prismatic mode. So I'll take the example of a prismatic shape of a cell, and you can, once I select this, you can see that we can mention the thickness, the length, the height of the back of the cell, and if you want to model the properties, I hope it is clear, the scene is visible, right? You can even, am I audible? I don't see any response. Am I audible, ma'am?
Yes, sir, you are audible.
Yeah, and the screen is visible, right?
Yes, sir.
Okay. So even the cell properties like mass, capacity, and energy can be mentioned. Then you can the and by if you are looking for some other vendor who is already the manufacturer of any cell, you can select from these kind of vendors. Like if you want the parameters from Sanyo or Panasonic, you can select that, and then the part number for that particular vendor can be chosen. For example, if I choose this and apply from data, so all the data will be imported for this particular part number. So as of now, I'll stick with the basics, and then also the cell properties where you can say the temperature dependence, the open circuit voltage, or if you want to have the short circuit current. So I'll be focusing on open circuit voltage, the capacity. So all these parameters can be specified at different stages rather than using a SimScape and developing the components and parts individually. So a large battery pack will have that much of thermal components and the electric circuit which is involved. So so if you are on core domain of battery management system, the suggestion is to do the fundamentals in MATLAB and then go to the battery builder. But if you are working on just you know all the parameters of your battery, the shape required for your battery, then it's easy to use the battery builder. Uh, uh, while mostly, which is also used in industry as well. So if I go to apply, so you can see a single cell of prismatic shape has been created with the necessary dimension. So once a cell is created, then next step is to identify or to define the number of parallel assemblies of these cells which is required. So for that, again go to the parallel assembly and change the name to uh, parallel assembly, and stacking, you can stack the position. And now then the next step is to select the cell which you have already created So I have created a new cell for price called as COE, and that cell is selected. Now you define the number of parallel cells. Right. So if I say 3, 4, so 4 parallel cells is required. You can define the topology for stacking. It can be single stack or hexagonally stack or n stack. So or single. So I'll take a single parameter. Then the rows can be defined. So if I take 2 rows and then apply to this. So now we have developed a 4 number of parallel cells of the initial cell which we have created. So once this is done, then a module can be created. So click onto the module and rename the module, and then select the parallel assembly name, and then here you can define the number of modules required, maybe one, so 2, 3, 4 modules. And if you want to give thermal or like parameters like inter cell thermal path, you can click onto this, and then where you have to place your cooling plate, maybe on the top or on the bottom, or both, or top and bottom, and then apply. Change this. So, but before I have not defined the thermal plate. Sorry for that. So now we can see the stack. Okay. So the module is created. Once a module is created, go to the module assembly and rename it, and then select the module. So add as much, like whatever number of modules is required, add to it. Click OK. Then number of levels, if it is 2 required, you can do that, and then you can see the module assembly is done. Then finally you can pack this module assembly. So going to this, selecting it, add. I'm adding 2 packs, and then apply. So the final battery pack is being designed. So this parameter, so what we will do is that once it is created, we will create this as a library function. So I can save this as a new library function. So create library. I'll change the name. Sorry for that. So now if I go to my folder, change it somewhere. Here you can see once the library is created, you can see the changes here. So finally, our math function for the library function for MATLAB is created here, and this library or this math function can be used while you are doing your experiments with EV. So you are creating by using the battery build apper, you are creating your own battery pack module, and this function can be used like whenever you require in whichever electric model which you are working with. So I hope this is somehow like battery builder is like understandable. Then coming to the all these are uh, part of the circuit or the modeling of the battery management system. So and you can have like I'll share this PPT, and for understanding more on battery management system, there are set of like articles or white papers available for battery modeling along with videos and documentations in MacWorks site itself. So I'll share this uh, uh, PPT as such. And coming to the main part, which I want to show you all was the another applications where application in MATLAB where uh, you can easily work with rather than building the end-to-end vehicle body or vehicle structure, which is known as the virtual vehicle composer. So this app is used to build a end-to-end virtual vehicle. Okay, so how to do that? To start with, like open your virtual vehicle composer, go to new, and you can set up all the vehicle parameters here. Like if you are working with a car, a four-wheeler, then you can choose that. Otherwise, you can choose a motorcycle or a bike. Then the model template is either Simulink or Simscape. So I'm taking a Simulink. Then the powertrain architecture, there are different powertrain architectures available by default in MATLAB. So if I take conventional vehicle or electric vehicle. So as you see, if I change the uh, vehicle powertrain architecture, you can see the different structure or layout of the vehicle that is coming over here. Then this is the vehicle dynamics, and once the initial setup is done, confirm the setup. So a project file will be populating here. So this is an interface where you will be once your vehicle structure and all the uh, like powertrain architecture is defined. Next thing is to provide the data, necessary data of a vehicle. So starting from the mass of the vehicle, the distance, the the front axle, the rear axis distance, the vertical distance, the moment of inertia, uh, all the aerodynamics, all these parameters or values can be defined based upon your area of study. So by default, MathWorks has created a basic like parameters, so you can edit on this and change these values as such. Then once it is done, go to the scenario and test. So here you will be defining your drive cycle, okay, or a wide open throttle. So I am taking the drive cycle, and there are many drive cycles available on based on different standards all over the world. So I'll be taking FTP72, and this will be my drive cycle. If you want FTP75, I can take FTP75. So based upon the required drive cycle which is required, I can choose that. Then once it is done, there are different signaling lists. So basic lists are already being given here, and then you can build your virtual vehicle. So it will take some time since I have opened the virtual vehicle composer for the first time today. It will take some time to build the vehicle. In time, I'll also show you another application in MATLAB, which is also important when you are working with EV. So this app is the scenario or the driving. Yes. Driving scenario designer. This is another application which comes as an add-on in MATLAB for those who are working in vehicle technology. Yeah. So I'll take you to this driving scenario designer in some time, but we have developed the entire Simscape model of the vehicle, virtual vehicle, and it comprises of, as you can see, the scenario. The scenario is the path or the situation where your vehicle has to be tested. The driver commands where you almost like we will be working with the steering tilt angle, the transmission, the acceleration. All this process will be the driver commands. The environmental conditions, the control parameters which is to be used, and this is the vehicle body. And then we'll visualize this based upon the different scenarios that is given as the input to the vehicle or the conditions that is being given. So if I run this, it will take some time because it's about 2474 seconds. So by the time I will take you to this driving scenario. So driving scenario app is an area where you will be testing your vehicle with different kinds of sensors. So the crux is that whatever you are developing in Simulink has to be tested somewhere in as if you are testing it in or visualizing it in a real scenario. So this is an area where you can test your vehicle by building your dummy vehicle, add sensors to it, and add the parts where the vehicle has to be tested. So how to do is that you need to add a vehicle. There are different kinds of vehicles that is available. So I'll take a car and I'll place this here. So I've opened many windows. I think that's some slow down the system performance. Yes, yes. So for that, I think the system has, yeah, it's running in the background. Yes. So once again, I'll go to the driving scenario, designer, take the vehicle, place it here. So this will be my vehicle, and now I'll be adding the like various kinds of sensors which is to be used. Maybe a camera can be added. Like I add a camera here, a front camera, a rear camera, and if you want to place 360-degree, that's also possible. You can add radar, you can add a lidar to this. The lidar may be kept somewhere here, and then you can add some radar sensor over here. So, and then finally you can also add your path where the vehicle can be tested. So I'll start from here. I'll move to here. Where any structure can be taken. Go like this. Yes. Finally double clicking it. You can see the structure where the vehicle has to be tested. Now, once this is done, you can add different obstacles to it, and then you can test the road in the vehicle using this road. So this is a view in which you can test your vehicle as such. And you can also, if you have a road runner application or a visual C++, then you can test it. This in, I don't have that, so the in 3D, this is two-dimensional view. If you want to view in 3 dimension, so you can also test in 3 dimension view. And this is a sensor canvas. This is a scenario canvas. So this is how you will be testing your vehicle in. So I have not defined the entire parameters because of the interest of the time. My aim is to take you to different tools and applications that are available to work with in MATLAB. So so this is another app which is to be used. Then you can also create your uh, virtual environment as such, like road runners, and then different environments where you can actually see visualize this. So for that you need to have a 3D display, applications or installed in this in your system to virtualize or visualize it in 3 dimensional form. So that's just another applications which application in MATLAB for EV or any vehicle type category. So once you develop this, I have put it this across my PPT. So this is the uh, like uh, the powertrain block set, which is, so how to access the powertrain block set is go to MATLAB and go to the like Simulink page. You can open a Simulink page, then go to the uh, new model, go to library browser, and go to Simscape. You have Simscape multi-body, you have driveline, all these are there. Along with that, vehicle dynamics, here you will get the powertrain. So all the powertrain toolboxes are available. Now, and then I have given the list of library blocks which is available in MATLAB. And you can see once the program, because it takes some time, we have developed a video representation of the program which is running in the background. So this is how we will be, once you click the run button from this, so you will get the necessary output like velocity, the speed of the motor, the battery state of charge, the, if it is a hybrid vehicle, then the fuel economy, all these parameters can be analyzed. So to have a further understanding on this, in MATLAB itself, you have a default powertrain block set available by going into the Simulink workspace. So I go back and open the Simulink, then go to the Simscape, and then what vehicle dynamics block set. If you want to work with state of charge, then there are different examples, direct examples for state of charge block. So how can you all access this is that go to Google, and you can look for MathWorks documentation on powertrain or driveline. So you can see all the documentations and examples that is available in MathWorks. So all the examples are simulated examples. So suppose if you want to work with any of these areas, uh, So we can just, like for example, like threshold parameter tuning. So if you want to work with threshold, understand what is threshold parameter tuning, click onto this particular link, and you can see the model over here, the tested model over here. Either you can open this in MATLAB online if you are part of the campus wide license, and if you have installed, then copy this command, go to the command window and place it and open this. So all the required documentations will be opened here, and if you want to work in with the same Simulink model, it's created over here. So this is how we will be working with, like understanding and analyzing each part of your like vehicle, and then from that you have to grow to, let me start from the very basics and then move into the advanced features of by using the applications. So stating that, so this is the reference applications which you can find it in powertrain block set in Simulink, and this is the vehicle dynamic block set which is available. So ride and handling, for this ride and handling, chassis control and ADAS features. So all these are the additional vehicle dynamics block set which is found in MATLAB, which you can download it as an add-on from the add-on menu. So these are the vehicle dynamics block set features. And this is a Simscape vehicle template. So I have shown everything in Simulink. Now this is a Simscape. If you are selecting the Simscape environment, then you can see this as a Simscape virtual like vehicle environment as a real-time vehicle itself. And you can give your parameters in this, change your whatever necessary parameters, whether it's the shape of the vehicle or the degrees of freedom, where if you are working with 3 degrees of freedom or 7 or 15, whatever number of degrees of freedom you are working with, you can select the degrees of freedom, the number of motors, the axle type. All these parameters are mentioned here. Maybe like better understanding will be there for more mechanical engineers in this uh, vehicle body analysis, and to have a how to learn on electric vehicle technologies, that if you are part of the campus wide license program, you can start with the MATLAB basic on ramp, followed by Simulink on ramp, and this is Simscape on ramp. So once all these certifications comes with free of cost as part of the campus wide license, and then there is an additional MATLAB chapter which is or TS which is available, or as known as motor control series, and then go to MATLAB documentation and work with the reference models that is available in MATLAB. So this is so if you are working with electric vehicle technology for as a part of your research or in lab, you can write to me. This is my mail ID and contact number. And also, if you are part of the campus wide license, we have a curated. Maybe my colleague Dave might have on the other day might have told you about the modular curriculum which MathWorks has developed, and I can also share the modular curriculum. So the modular curriculum looks like this. Just a second. So meantime, if you have any doubts, please ask so that I can also have an understanding uh, on this. So this is the modular curriculum which is created by the MathWorks team. So it starts with the course overview, the basic programming introduction, how to solve the ordinary differential equation, then started with a simple vehicle model. So all the examples will be given in this. So using basic live script, how you can model a vehicle, and then a model introduction to model based design, DC motor control, the power electronics part, hardware code generation, PLDC and PMSM motor control, then the battery management system, the thermal modeling, the powertrain modeling, followed by the vehicle dynamics, and then the entire EV system model, and finally the overall, like integrating all these components or parameters together, what will be the overall structure and analysis of the EV system. So those who have MATLAB access, we can share this entire course structure to you so that you can work at starting from chapter 1, and then finally you can model your own vehicle. So that's what I thought to present today. So I know that I'm a bit fast in this because the entire course is about 60 to 80 hours of actual hands-on process. But my intention today was to just to give a heads up on the tools that are being used in MATLAB if you're working with L2 if you have any doubts, please do ask so that.
But please, now we cannot bring out regarding the session, or we can type it in the chat. That it seems very
Sorry,
topical.
I think like you are not audible.
So we are moving to the next procedure. So I invite Devanshi.
Thank you so much, sir, for that highly informative class. As a token of our gratitude, we are delighted to present you with a virtual memento and certificate.
Thank you. And I have added the modular curriculum to. I'm going to add the modular curriculum to the chat. Just give me a second. So you can access this the entire course of EV from this modular curriculum if you have access to the MATLAB or yeah, your campus-wide license, or if you have registered officially with MathCode site, so you can access this and all the modules which I have shown there will be reflected in your MATLAB as well. So you can start working with this. Thank you. Thank you. Thanks a lot. Thanks, Yuji ma'am, for inviting, and Ravishankar sir for giving the opportunity to showcase on MATLAB. Thank you.
Thank you, sir, once again for being with us today and for sharing your valuable insights. Thank you.
Thank you.
we will have a break now, and the next session will start at sharply at 3:30 p.m. Good afternoon, all. So, good afternoon, one and all. We are moving to the second session of the last day of ADAL-FTP on emerging trends in electric vehicle. So now we have with us Dr. T.D. Subhash of CGN University, Ocean University, China. And he will deal with the battery technologies and advanced BMS technologies. So for the official introduction of the resource person, I invite Devanshi, Student Branch Chair of IEEE Student Branch, Christ College of Engineering.
Thank you, ma'am. It is my privilege to introduce today's distinguished guest, Dr. T.D. Subhash, an eminent academician, researcher, and IEEE leader whose contributions have left a remarkable footprint in the fields of photonics, nanoelectronics, and renewable energy technologies. Dr. Subhash currently serves as a professor at Zhejiang Ocean University, China. With over 74 research publications and more than 400 citations, his research spans photonics, semiconductor device modeling, advanced solar cell technologies, LED quantum efficiency enhancement, IoT enabled systems, and blockchain based trust frameworks. His innovative work includes developing IoT based flood surveillance systems and analytical models for next generation devices. Beyond his academic excellence, Dr. Subhash has played a pivotal leadership role in IEEE. He was the founding chair of the IEEE Photonics Society Madras chapter 2015 to 2020, during which the chapter won multiple global recognitions, including Chapter of the Year 2017 and Most Innovative Chapter 2020. He is also the organizing chair of the IEEE 5 Nano International Conference Series and currently serves as the Global Strategy Representative for India on the IEEE Photonics Society Globalization Committee. Dr. Subhash's career is a perfect blend of teaching, research, innovation, and professional leadership, making him a role model for both faculty and students alike. On behalf of the organizing committee, it gives me great honor to welcome Dr. T.D. Subhash to this faculty development program. We look forward to gaining valuable insights from his vast expertise and inspiring journey. Over to you, Dr. Subhash.
So thank you, Devanshi, for your wonderful introduction. So hope my video, audio are perfect.
Yes, sir. Yes, sir. Yes, sir. Your audio is clear and your video is visible.
And my screen is also visible.
Yes, sir.
So then shall I start?
Yes, sir. Yes, sir.
So good evening to all. First of all, I appreciate and congratulate the entire organizing committee for conducting such a wonderful program, which is funded by AICT. And now we are at the end of the day. Hope you all learned many things about EV. So I'm just covering the battery technologies and BMS. So the next 1 hour, the section, it will be something about the basics of batteries. So which is used for mobile, solar and EV. Then some battery technologies will be useful for electric vehicle. Then advanced battery management system. At the end, as I am representing China, in the past 1 year I am in China. So I can provide some insights and some questions. I can answer, I can provide something based on the career opportunities in China. And also at the end, if the participants interested, I can answer a couple of questions and some interactions around 15 to 20 minutes. That's what my plan. Let's start with the basics. So first we can see about start from power and energy. First, let me differentiate power and energy. Power and energy are not same. They are different things. So if you want to travel 1 kilometer, so you can travel 1 kilometer in 10 minutes. At the same time, you can travel that 1 kilometer, travel or reach that 1 kilometer in 5 minutes, which means you need to run faster. Run faster means there should be some extra power. Clear? So total energy required for both is same. So reaching 1 kilometer in 10 minutes and reaching 1 kilometer is 5 minutes, it's same. But the energy is same, but we need some extra push or extra power. So a distance from A to B, the travel distance is 1 kilometer. So more power will be required to cover distance in 5 minutes, and less power is required to cover the distance in 10 minutes. So both cases, same energy is required, but power different. Same as like that, how you will be calculating your electricity in home. The machine which runs faster requires large power. The motor which runs faster, a big motor which requires more power. So here power and energy is different. So how will be, the market, you will be asking, are you purchasing LED or fan, motor pump? You will be specifying the power rating. In market, you will be asking the power rating of LED and you will be purchasing. And where you get the power rating, normally it will be in the equipment, maybe the outside cover, or will be in the applicants and the applications. The LED or whatever it may be, a fan, itself the power rating is mentioned. So unit of power is watt. For LED, you will be asking 1 watt LED, 2 watt, 5 watt, 10 watt, etc. And for fan 20 watt, 50 watt, etc. you can purchase. So as I mentioned, bigger water pumps require more power, bigger fan requires more power, bigger motors requires more power. So how you can calculate the power ratings of all applications in your home? First, you can take, there will be, if there is a small house, you have only 2 fans, fan 1, fan 2 you can mention. So fan 1, it is 70 watt, fan 2 is 50 watt, some LED is 10 watt, 50 watt, whatever maybe. Like this, you need to mention all the appliance names and power rating. Finally, you need to calculate the total power rating of the appliances in your home. And consumption of electricity by an appliance in a day. So here, power energy is different. So the capacity of a machine to do some work is nothing but the power, and the measure how much energy has done or how much work has been done. The measure of how much work has been done by a machine or appliance is called energy. So power is nothing but the capacity of a machine to do some work. Energy is nothing but measurement of how much work can be done by a machine. So machine without doing any work, maybe some machine will be in idle, which means there is no energy. Clear? So how much time, then is another thing is how much time it works. It's very, very important. So how much time a LED will be glowing, maybe if 2 hours, 10 hours. So it should be different. So unit of power is watt, unit of time is hour. So the unit of energy is watt hour. So power is what? Duration of how much hours it will work. It is hour. That is total energy. So energy equal to watt into hour. So let us calculate the LED power consumption for 1 day in your house. So the LED will be working for a 10 watt LED is working for 10 hours. So that is 10 watt into 10 hour is equal to 100 watt hour. So you can calculate it for 1 month or 1 year. So into 30 for 1 month and 12 for, and again plus into 12 for, so for one year. So 10 volt into 10 hour per day into 30 days, which means 300 watt hour per month. Similarly, we can calculate energy consumption by all appliances on a per day basis, per month basis, or even per year basis. Then 1 kilowatt hour equal to 1 unit electricity. That is, if energy consumption is 1000 watt hour, so we say 1 kilowatt hour. So the unit of electricity is kilowatt hour. So 1000 watt hour equal to 1 kilowatt hour. Same as like the 2000 watt hour equal to 2 kilowatt hour. So 15,000 watt hour equal to 15 kilowatt hour. So by using this, we can find out energy consumed by an appliance in a given day, in a given month, or an entire year. So the power is nothing but the capacity to do work, but how much work is done is nothing but the energy which is measured in kilowatt hour. So this is the tabulation so that you can calculate the entire usage of electricity in your home. You can do an energy auditing in this case. So in the first, you can put number of appliances used and how much power rating for each appliances and how much day, per day, how much time, maybe 1 or 2 or 10 hours, something like that, you can calculate. Then you can use in watt hour, then month, then per year, you can do the calculations. Now we can see the basics of batteries. So battery is nothing but it has only three things. One is the charging capacity, then terminal, the voltage, there are two terminals, the voltage terminals, then how much energy can be stored. Then the batteries are the major part, the heart of an electric vehicle. So what is a battery? So it's nothing but it's used for charging. I mean, charging and recharging mobile phones, electric vehicles, solar systems, etc. So something need to charge. So when the charge goes down or it decreases, we need to refill. I mean charge. So battery is a tank of charge. So water tank means it can store water. So battery means stores charge. So we can refill it once it is completed. So what is the unit of charge? So battery charge is given in terms of ampere hour. So it is nothing but AH. So unit of charge is ampere hour. So how much battery? So how we will be purchasing a battery from a market? How much battery charge capacity available in the market? That is 2 AH, 10 AH, 100, 200 AH, etc. Small battery capacity is given in terms of milliampere. So that it can be termed as 200 milliampere. For example, if you are using two-wheelers, electric vehicle means that it is will be less. So it is 1000 mAh battery, 5000 mAh battery. So 1 mAh equal to 1000 Ah. So typically the capacity of that charge tank is given in terms of ampere H. That is Ah. So as bigger the capacity, bigger the charge tank. So if the capacity is 100 Ah, it is bigger tank. If the capacity is 150 Ah, so more bigger tank as it is goes on. So there are two, as I mentioned, terminals. There are two terminals, positive terminals and negative terminal. So terminal voltage is the potential difference between two terminal of battery. So this terminal voltage is nothing but it shows how strong is the driving force of the battery. So bigger the terminal voltage, higher driving force. Then the terminal voltage is given in terms of volts, or you can mention as V. So it's available in the market as 2 volt, 4 volt, 12 volt, etc. So we can also connect many batteries together to get more volt. So if we have two batteries of each 12 volt, then 12 volt plus 12 volt, it is 24 volt. Some batteries have terminal voltage of 3.2. Also, it depends. So connect many batteries to get higher voltages. Then there are two important ratings of batteries, that is terminal voltage and charge capacity. That is terminal voltage is mentioned as V and charge capacity is mentioned as ampere H. That is 7.4 volt and 2600 milliampere. So this is very, very important. So we have to concentrate on total energy that battery can store. So how much energy a battery can store? Energy stored in the battery is nothing but terminal voltage into charge capacity. So battery energy equal to volt into charge capacity, the unit is ampere hour. So it is voltage ampere hour. So it is just nothing but power into hour. The unit of power is watt, that is watt hour. So unit of energy is nothing but watt hour. We can mention as WH or WHR. An example, if 12 watt battery rating of 100 ampere hour, how much is the energy stored in the battery? So it's a question. So it is nothing but 12 watt battery is have the rating of 100 ampere hour. So it is 12 watt into 100 ampere hour, which is nothing but 1200 watt hour. So unit of energy is watt hour. So 12 watt into 100 ampere hour equal to 1200 watt hour. So 1 unit of electricity equal to 1000 watt hour, which is nothing but 1 kilowatt hour. So energy stored in 12 watt 1000 ampere hour battery is nothing but 1.2 watt hour. Or we can say normally in terms of electricity, we can say 1.2 units of electricity. So types of battery technologies. So battery technologies can be terms are selected based on 4 parameters. That is extractable energy, how much energy can be extracted from a particular battery. Then price is very, very important. Then the lifetime of the battery. Then thing is maintenance. So there are many types of batteries. So two commonly used technology which we might aware is lead acid batteries. So many two-wheelers or even cars will be seen, which is toxic, because lead is toxic and there is an acid. Another important thing is lithium ion batteries. So Lithium-ion batteries is mainly used in mobile phones and EVs, so we need to concentrate more on lithium-ion batteries, which is the current technologies available in electric vehicle. So there are many other types of batteries that help of this material. So nickel cadmium batteries, nickel metal, many based on the applications, it will be selected that we can see. So here we are focusing on lithium and batteries. So the battery cell is most basic unit of batteries. So using many cells, we can make battery packs or bigger batteries. So cells into modules like this, the pack will goes. So if a lead acid battery cell give 2 volt, as I mentioned, a single cell has 2 volt, we can connect many cells. So each yes, if you're taking one cell for 2 volt, another cell for 2 volt, so it is 2 plus 2 equal to 4 volt. So like this, we can connect the series. So combining many cells to form big packs. So 2 cells to form 4 volt, combine 3 cells. It's based on our need. We can combine as much as cells to form big packs of batteries. So how much energy we can take out from batteries? So it's very important question. Even nowadays, when we are charging our mobile phone, we used to think so whether we can go for 100 plus or we can put overcharge. So this is a big question. So normally it does not go to high as I mean we cannot fill it as a time. It should not drop to the 20%. That is a concept. So I can say it should not be go to less than 20% and should not be go to more than 80 or 90, so that you can increase the life of your battery. So example, in water tank, we can utilize all the water inside. I mean, till the last drop, we can remove the, and you can take the water from the water tank. But in battery, it is not possible. So you can't take all the stored energy. There is a term we call DOD, that is nothing but depth of discharge. That is percentage of energy that can be taken out from of a battery. So it also gets varies depend upon the batteries. So the depth of discharge of lead acid batteries is 50%. Depth of discharge of lithium-ion battery is 80 to 90%. So if the depth of discharge is 50%, then 50% of stored energy can be taken out. For example, energy stored in 12 watt 100 ampere battery is, that is 12 watt into 100 ampere, or it is 1200 volt hour, or you can tell us 1.2 units of energy with 50% depth of discharge means only 600 watt hour of total stored 1200 watt hour can be taken out. So notice nothing but in lead acid batteries, if actual requirement of electricity is 1.2 kilowatt hour, then you should store double, that is 1.2 into 2, that is 2.4 kilowatt hour of energy can be stored, because it's 50% depth of discharge. So if your requirement is 2 kilowatt every day, and if you are using with a battery with 50% depth of discharge, I mean the lead acid batteries, you have to store it double, that is 4 kilowatt hour. So you can, using this trick, you can resize the batteries for EVs. So in case of lithium-ion battery, suppose 11.1 watt into 10 ampere, it is total 111 watt hour. So depth of discharge is 80 to 90%. So you can put 0.9, so it comes around 99 watt hour. So these are the difference between lead acid and lithium-ion batteries. And life is plays a vital role. How long does the battery works? The life of battery is given in terms of charging and discharging. It called as a cycle. How much times you are charging, how much times you are discharging. So by this you can estimate the life of the battery. For lead acid batteries, it gives 800 to 1500 cycles, and also the maximum warranty is 3 to 5 hours, which means one cycle is nothing but one charge and discharge cycle in 1 day of life. So normally, as I mentioned, in market they give warranty of 5 years, and if you manage well, we can use it for 6 years and more. And lithium-ion batteries gives 1200 to 2500 cycles, that is 4 to 8 hours. So comparatively, lithium-ion batteries gives more life. That is the reason now we are using lithium-ion batteries. And lead acid batteries have low depth of discharge and comparatively shorter life. Lithium-ion batteries have longer depth of discharge and yes, a longer life. Now we can see the evolution of EVs and batteries. Why EVs? What is the need of EVs is, one is zero emission. Second one is energy transition. And of course, there are a lot of policies or some, some allowances provided by the government. So if you see the global market, so China comes first in terms of manufacturing as well as selling. In 2024, 11 million electric vehicles are sold in China. And now for 2025, they have fixed the target is to sell 14 million electric vehicles. So India is also there. So you can see the graph from 2017 to 2027, how this market is increasing. So there is a lot of demands. At the same time, a lot of challenges also there, and a lot of new technologies are evolving day by day. So as I mentioned, battery is nothing but heart of electric vehicles. Of course, it's expensive. If you're constructing a solar system in your home, so more than solar cells, the entire 50% budget we need to allocate for batteries. That's the reason we are going for grid connection. Same as like that in electric vehicle, the battery it costs more. At the same time, another 5 to 10 years, 5 to 6 years we need to replace is another biggest drawback. So mostly in electric vehicles you're using nowadays is lithium and battery technology, which is expensive because the materials like lithium, cobalt, and nickels are using in this, which will increase the cost. So the cost of these materials combined with the manufacturing process, etc., will increase the cost of the electric vehicle also. So based on this capacity, the driving range of electric vehicle varies. For example, driving range is nothing but how much kilometer we can cover. It is called the range. So what are the factors which will affect the performance of EVs? So first one is battery capacity. Capacity is nothing but how much power can be stored in the particular battery. And so range is nothing but how much kilometer or how much distance we can travel. And density is nothing but the weight or size of the batteries, which also plays a vital role. Then battery regularization. As the battery ages, its capacity decreases. For example, if you're purchasing a mobile phone, initially, if you put charge for 1 day, we can use for 2 to 3 days. But when it goes to 6 months to 1 year, automatically we need to charge every day. That's the same thing. It's called battery degradation. Then power output is very, very important, because when we are in the vehicle, if you have a heavy load, or if the vehicle wants to to climb hills with these immediate power accelerations, or immediately we need to top the speed. So power output is very, very important. Next is peak power. There's sometimes as the battery ages, as long it goes for 2 to 3 hours, what happened? The peak power start declining. Then thermal management is very, very important, because a lot of dangerous, sometimes it may be fire or burst, etc. So thermal management maybe happens due to the environment also. So it is very, very important. These are the factors we need to consider. And types of EV powertrains. So normally there are many, so I can tell something 5. First one is battery electric vehicle, which is nothing but it has an electric motor and a battery pack. It is called as battery electric vehicle. Then PHEV, that is plug-in hybrid electric vehicle, which is nothing but it has both electric motor and an internal combustion engine, that is ICE. Then hybrid electric vehicle is nothing but small battery and electric motor that assists ICE, that is battery charges via degenerative braking. Then mild hybrid electric vehicles nothing but conventional IC with small electric motor, which will stop for initially for starting and stop purpose, or for acceleration assistance. We will be using this mild hybrid electric vehicle technology. Then the last is fuel cell electric vehicle. Of course, it is powered by hydrogen fuel cells. Then fundamentals of battery is nothing but it works under the principle of electrochemical energy storage. Hope you all aware. Anyway, I will be providing some hints. So just nothing but here energy can be stored in the form of in chemical form. Here redox is nothing but reduction and oxidation and reduction takes place. So while charging, what happens? So the ions will move through the electrode, that is from anode to cathode, and the electrons will move towards the external circuit. So this happens in charging, and the reversible process happens in the discharging. So when an external force applied, ions will be moving. This happens in energy. So it happens in the charging phase, which means electrical energy will be converted into chemical energy. In terms of discharging process, the things will be reverse process happen. So the charged things will be helpful to operate some device, which means the things will be the discharging process, the chemical energy will be converted into electrical energy. So it is called as a reversible system. So what are the fundamentals is energy density. So it's nothing but, of course, it's related to the weight, size of the batteries. So power density, when there is an immediate acceleration or immediate increasing in power, so power density plays a vital role. Then, as I mentioned, the depth of discharge, another concept is life cycle. That is number of times a battery can be fully charged and discharged. So a longer cycle life indicates a durable and longer lasting battery. For example, a battery with 2000 cycle life can be fully discharged and reach at 2000 times before needing replacement. It is called as life cycle of the battery. So then, same as like that, lithium-ion battery works under the same principle of system, that is a reversible movement. Here what happens is there are two electrodes, cathode and anode. So the source is nothing but lithium ions. So the lithium ions will be moving through the electrolyte and it blocks all the electrons, and the electrons will be flowing towards the external circuit. So here the separator will be used to prevent the contacts, and it will it will allow the ions to flow. This is the same concept of electrochemical reaction. And here the ions, which is we are using the ions as lithium ions for processing. So there are a lot of lithium ion variants. Lithium is the basic material we can tell. So I have mentioned few. One is lithium iron phosphate, and nickel, manganese, cobalt, and nickel, cobalt, aluminum. So there are many. So based on the materials, based on the applications, we need to choose which one is needed for our purpose. For each and everyone has its own drawback, pros and cons. At the same time, the cost also, as we are using materials, so the cost is also important. So for example, if we are using a two-wheeler, then we need to plan accordingly. If you are using a car, we need to plan accordingly. If we need to, for a buses or heavy trucks, we need to choose accordingly. The main factors we need to consider is the cost, energy, power, safety, performance, and lifespan. So these are the 6 things we need to compare, as well as based on our application we need to choose. Because as we choosing high variant, of course the cost is also increases. This is another, and we can compare all lithium ion variants in a single slide. So the factors we need to consider is cathode, anode, which materials is used, and the safety is very, very important, because you might have heard about the two-wheelers are bursting, firing you might have seen in social medias. Safety is very, very important. Then power density, energy density, of course, cost, lifetime, how long it will be used, then battery energy storage system performance. So each and every, you can see, if you see, each and everyone has its pros and cons. So based on our application, based on our need, we need to choose which lithium ion variants is sufficient for our device, or we can tell our vehicle. So emerging battery technologies. So as I mentioned, now we have lithium ion batteries, sodium ion batteries, metal air batteries, flow batteries, etc. Each one is for different applications. But now the current trend is going on solid state batteries, which is made up of ceramic electrolytes. So it will increase, it can ensure the safety. So from 1970s to 2020, now it's 2025. So again, it's the research is going on, a lot of developments are taking place, 2030. So in 1970s, our organic electrode, that is concept of lithium ion batteries evolved. And 1980s, what happens is rock salt structure introduced with lithium ion batteries. And around 1980 to 1990s, the commercial purpose lithium and the manufacturing of lithium and batteries and the application of commercialization evolved in 1990s. The name is LiPon, that is lithium oxide concept. So more safer batteries introduced in 1990s. And what happens 2000 to 2020, so some other materials which is linked with lithium and some safety features also evolved, so that they are able to manufacture less cost batteries with the help. Then so in the introduction of orthosilicate cathode materials evolved in 2005, and 2015 to 2020, so another huge development of high voltage cathodes evolved in this particular 2015 to 2020. And 2020 to 25, now the development of lithium silicon batteries, or we can say it is solid state batteries. And 2025 to 2030, we are expecting another major development in this battery technologies, that is lithium air battery. See, the major problem is, one is fast charging, second one is size plays on vital role, so size and weight. Then how long is the lifetime of the batteries, so how much time it can be stored. All those things are the big factor when we are designing an electric vehicle. So key battery parameters and performance. So the first is electrical parameters. So voltage, there is open circuit voltage is very, very important. So we need to monitor the importance of full operating voltage, so to prevent over or under voltage events. So both is important, over voltage and under voltage events. That's capacity. So just nothing but, so how much usage of battery, that is usable capacity of the batteries. So here BMS plays a vital role. Then C rate, which is nothing but one C rate means how much time it's fully charged and discharged in 1 hour. That is called C rate. C rate is nothing but measure of the rate at which a battery is charged or discharged related to its maximum capacity, which is C rate. So then state of X matrix is nothing but, SOC is nothing but state of charge, which is nothing but showing the status. You can state fuel gauge of the battery, 0 to 100%, how much can be used. Then state of health is nothing but the battery's total capacity. SOH is nothing but measuring the battery's total capacity. That is, if 80% SOH means it can only hold 80% of its original charge. Then state of function, which is nothing but how much power the battery can be deliver or accept at a specific moment. So this is what the architecture or the cell battery pack. So it consists of a cell. So as I mentioned, if you want a 6-volt battery, if you can take 2 volt a single cell, means you need to take 3 cells. So it is so that by adding all those things, by connecting all the cells in series, we will be getting 6-volt battery. So first it is a cell, it can be made into module, then combined to a pack. This is the hierarchy for the development of full pack battery. And these are the structures. So aluminum crash structure, in under this there is a housing tray, then battery frame. So there's a cooling system, because so when it heats, a lot of temperature evolves. So there are a lot of cooling mechanisms available, that is air cooling, liquid cooling, immersion cooling, etc. Then cell module, then lower protection cover. So, and of course there is some gases also evolved, because carbon battery consists of carbon. So when carbon heats, so it will be a pollution. So this also we need to keep in mind. So, and failure or battery safety is very important. So batteries typically operates between 20 degree to 25 degree. So safer limit is 45 degree. So battery overheating happens. What happens? So of course there will be some damages happen. So it leads to firing also. So charging a battery too quickly or beyond its rated capacitance also, capacity generates excess internal heat. So that we need to consider. Then high electrical load. So due to this also, the bikes or the electric vehicles the damages happen. So this increases internal resistance and causes temperature spikes. Then high ambient temperature due to hot weather or poor ventilation. So also the heat will be increases. Then aging, of course, aging is nothing but the life duration. As maybe it takes more 3 to 4 years, aging happens. So this is one reason. As also poor quality cells also leads to dangerous. Then physical damages or internal short circuit also has, it also reason for the increase of heating and rise for fire. So all these systems can be managed by BMS, which is nothing but battery management system. So this is the architecture of battery management system. There is lithium-ion battery pack. So the entire pack is controlled by a lot of sensors. The sensors will be measuring the voltage, current, cell voltage, temperature, etc. If there is any peak or beyond any variations happens, these sensors will be sending data to the data aggregator. The data aggregation will be get the data along with the along with monitoring them SOC, SOP, SOH, SRU, just nothing but the health as well as the lifetime or any changes will be monitored by the sensors, and they will be giving signal to the master controller, and the entire data including the terminal management the data will be sent to the display as well as in cloud management. So this is advanced battery management system. So this will be available in all electric vehicles. So if there is any changes, any things happens, extra temperature increase will happen, so signal or any alarm will be set in the management system. So some core functions of this modern battery management systems are dendrite formation, which is nothing but it happens inside the chain reaction, inside the battery. A tree-like structure or a spike-like structure happens inside the battery, which leads to internal short circuit. So this is another problem. The next problem is overcharging and over discharging. This will also leads to fires, etc. Then thermal management is nothing but temperature increases due to overheating or some problems with the cooling mechanisms. So thermal management problem also arises. Then safety is nothing but this cell monitoring and data acquisition will monitor the thermal runaway. Thermal runaway is nothing but which will happens in the chain reaction inside the battery. Due to this overheat happens. Then fire hazard, of course, some short circuits fire maybe happens. As I mentioned, in battery there is what you called the toxic gases evolved. So because graphite and carbon are there in this battery, so some toxic gases evolved due to overheat. So this also leads to fire or some problems to the humans. Then performance. The performance also will be monitored by these battery management system. So battery balancing. Balance is nothing but whether the energy stored is fully utilized or we are maximizing the usable energy. Then accurate SOC and SOH. Whether the pack's remaining charge, and it will also monitor the health of the battery. Then major important thing is longevity and reliability. So longevity is nothing but the duration of the life of the battery before its performance starts degrading to a specific level, which means, for example, so before a replacement of a battery, so after 5 years we need to replace the battery. Before the replacement of the battery, how long the battery will work? So this is called longevity. Then reliability is nothing but consistently need to provide the the performance. So this is reliability. So these things will be monitoring by this BMS. So another major function of this BMS is nothing but cell balancing and temperature monitoring, which is nothing but it will keep all the cells in equal and safe condition. Then high voltage isolation monitoring, which will detect and drop. If it will detect any drops happens and send fault code to the system. And high voltage conductor is used to handle high arc suspension and life cycle switching. So this will be used as a conductor. And galvanic isolation will separate two electric circuits and it allow safe transfer of power to the electric vehicle. Then protection plays a vital role. So because it will prevent catastrophic failure by continuously monitoring hazardous conditions and triggering safety. For example, if any heat or any sudden rise in heat or anything happens, there will be safety relays. So this safety relays, as example, conductors. So it will be there to disconnect the battery so immediately. And of course, temperature sensors to detect early signs. These are some of the protection systems which will be available in the modern battery management system. Then future trends in battery technology. So as I mentioned, now the trend is solid state batteries, lithium sulfur batteries, recycling, and second life battery. This plays a vital role because now we are talking about waste management. I mean, plastics are it's cure burning plastic. A lot of problems we are facing, and now, as you know, day by day we are using these electric vehicles, the batteries. So after 5 years, what happens? So recycling as well as second life of batteries plays a vital role, so that you can utilize this battery. Already there are some mechanisms. So if you concentrate or if you do some more innovations in that, so that the second life of batteries can be increased, so that you can reduce the cost. Then smart battery management system with AL, ML technology. So these are the areas where you can concentrate in the forthcoming years. So then conclusion, key takeaways, future research direction, importance of sustainable battery that you have mentioned. So key takeaways, nothing but, for example, let me clear, as I'm in China. So in China, everywhere we can see, almost all houses we can see electric vehicles. I can say even in small villages, they are using electric vehicles. Even I can say there are more than 95 percentage people are using electric. I'm telling about electric two-wheelers. I've rarely seen petrol bikes, hardly, maybe 2 or 3 I have seen. So everyone is using electric two-wheelers, and we can see charging stations everywhere in all the apartments, shopping markets, institutions, everywhere. Electric. Even there is a shed for the parking. There is a parking slot or a shed for by dropping this vehicle, there should be some charging stations. And for electric vehicle cars, I can say more than 50 to 60%, because the persons who are traveling for long distance, maybe 4-5 hours travels, they used to use petrol vehicles. Mostly everywhere they are using electric cars. Almost 60% people are using electric cars. That's what, as I said, in 2024, they have sold 11 million electric vehicles. So now the target is 14 million for 2025. So even in India, it's booming. So a lot of drawbacks, challenges, those things will be overcome in the future days. A lot of research are going on. So I'm sure this electric vehicle plays a vital role in our day-to-day life. Then important thing is, this is an electric, it's not electric, and you can see the top, a solar vehicle. It is solar bar electric auto rickshaw for differently able person, which is developed by our students. It was done 2 years back. Actually, it's a student project, academic project. So my suggestion to them, faculty members, is, so if you're learning something, we need to, apart from getting certificates, you need to take this or convey this message to your students. Or you need to transfer the technologies which you learn to your students and make them to create some impact in the society. So by the way of developing new products, new prototypes, and at the same time, you can publish some papers. They can contribute. They can contribute the product, or they can exhibit those in exhibitions, getting some prizes and making patents, publish some papers. In that manner, you need to bring that output. So this is one of the vehicles. So this is based on, it will be charging with the help of solar. At the same time, we can also use direct charging for this particular system. The entire system, this auto rickshaw was developed from scratch, that too from scrap materials. So very low cost, we have developed this auto. And this happens 2 years back, 2023, past out students has developed this until it is working condition, providing good efficiency. and now it is available in Kerala. If you want this, I can provide the institute name also. So my suggestion is, so it's a simple example I'm showing. So everyone should do, your students should do some academic based projects. So every engineering students who are passing out need to do some projects, but my suggestion is the project should create some impact in the society, which is very, very important. Of course, everywhere a lot of fundings are available. In fact, we have in IEEE, we have epics in IEEE. In a year 2 times the call for is there. Now there is a call for which starts by September 1, and the project proposal application portal open, and it will be closing by October 1. So if any projects are there, you can submit. It's not project. If you have any ideas, you can submit the application. The condition is in a team member, at least one team member should be an IEEE member. That is the only condition. So another members, it's not mandatory for them to be an IEEE member. So the only concept is, the idea you need to develop a project which will helpful for the community, and we need to get a letter from an NGO. So because the funding amount is $10,000 maximum, minimum it is $2,500. It's an 1-year project, and the condition is the students will be developing. We will be providing 10,000. IEEE is providing $10,000. The students will be developing a project, and they will be handovering to the community, and they will be leaving the campus. So we are providing $10,000. But we need the product should be there, sustained. So an NGO to take responsibility that the project or the product will be helpful for the community for another 5 to 10 years. This is what the commitment we are expecting from the NGO. So an NGO's recommendation letter is needed. Rest you can submit the proposal. Simple questions are there. So there is epics and IEEE. You can directly get support. That is up to $10,000. The application portal starts by September 1st. So I request all the faculty members. So because it is the right time, almost your students have started doing projects. So you can get some funds from IEEE and create some impact in the community. And as I mentioned, career opportunities in China. So as I was there in China for 1 year, so a lot of political conflicts you might have seen even during this Operation Sindoor, etc. So after 2020, after COVID, there is no direct flights from China to India. So now you might have seen in newspaper last week, the minister from China visited India, and now by August 31st, our Prime Minister is visiting China. So now a lot of new things evolved, new opportunities evolved. At the same time, I can convey a few things. The major thing is I have split it into 2 things. One is a job, that is job-oriented talent program. In China, they have 2 concepts, that is Chinese talent program. Why they start this initiative is, one is many Chinese students are same as Indian. So if you see major in US, so how many students studying their higher studies or engineering in US? So then the number 1 comes to India. Of course, second is China. So as many Chinese students go to US for higher studies, I'm talking about US, many foreign countries from China, they will be doing their masters or engineering or PhDs, and after that they will be working in that particular country. So now Chinese government want that students to bring back to their Chinese students to bring back to their home country, and they need to develop something for their nation. So for this is one thing. Second thing is they need to get this talent acquisition program. That means they need to bring the best talents from any parts of the world, and they need to bring them to their country to make them to work. These are the major 2 reasons they have evolved this Chinese talent program. That is talent acquisition program. It can be divided into various modules. First one is National Youth Talent Program. So it is the recruitment will be conducted by Chinese government itself. It's a national, same as we have India nationals and state. We have provinces. In China, we will be taking the state. In India, we have Kerala state, Tamil Nadu state, etc. In China, it can be state can be termed as provinces. So National Youth Talent Program, it's a 3 years program. So the duration is three years, and the age limit for application is 35 years old. 35 years. So you can not only in teaching and research, even industries, you can work in the industries. So the industries will also have under this scheme. Your salary will be provided by the government, not the particular college or particular company. Salary will be provided by the government. It's a 3 years program. So once 3 years completed, if the company likes, they will be continuing. But the government will be providing the salary, your research funds, travel, many things were there. It's something a pack, but it will be provided by the government. It is the highest position, highest thing. The second thing is 1,000 talent or young 1,000 talent. 1,000 talent means it is another talent program which will be based on province level. So as I mentioned, previous one is China government recruiting. Next one is province. Province government will recruit. For example, in India, we have Indian government program, state government programs. This is state government programs. It is province program. So this is also another level. Same as here. Here the age limit is 40. And young 1,000 it is 35. And here you will be getting same. Sometimes the salary will be less, but you will be getting good benefits. And this is for 5 years. So after 5 years, the government funding will be stopped, but the institution or the particular company will hire you, or you can extend. Then 100 talent program is something different. There is no age limit. I have seen professors from abroad, they're working 77 years old. I have seen the professor. And one of my colleagues, he is 71 years old from Ukraine. So this is nothing, but there is no age limit. So the well-known professors from the world, they will be hiring and they can work in China up to maybe 80 or something like that. I'm not aware of the age limit, but I have seen professors around 77, 78 years old who are working in China. So this is called 100 talent. This is one major program, that is talent program. Chinese government itself funding. It's for job oriented. Second thing is scholarships. So there are many scholarships. The major scholarship is Chinese government scholarship. Is a major. There is we call it as CSC, Chinese government scholarship. So under this scholarship, we can do undergraduate degree, postgraduate degree, and PhD. So undergraduate degree is nothing but the funding amount will be 2,500 RMB per month. For postgraduate, the funding amount is 3,000 RMB per month. And for PhD, it is 3,500 RMB per month. Next important, of course, you can also do the research there. Maybe it's a 2 years program, postdoc. That is postdoc innovative talent program. Here the funding is something huge for 2 years. That is 60 lakhs to 80 lakhs RMB for 2 years, including your travel, stay. Many things are covered. So these are the talent program as well as scholarship. There are many based on the provinces. Many are there. I'm just giving an overview of this talent and scholarship program. And you might have asked a question, sir, language is the problem in China. Of course, language is the problem. To be honest, I was here for 1 year, more than 1 year. Last June, I reached here. So more than 1 year, I know only 2 words, how to tell hello and how to thanks, but I am serving in China. Because we have translators. In mobile, we will be using translators. Of course, there are few Chinese friends who know English. So it's not a big task, but daily survival is a problem. So you can learn. It's not mandatory to learn Chinese. If you learn, you can. If you go to a shop, if you take a car, you can communicate. That is the only thing. But you can ask a question, sir, whether we call it as HSK level 1 to level 6, whether this Chinese language course or certificate is mandatory. Yes, because see, there are 2 medium of instructions, Chinese as well as English medium of instruction. If you are choosing Chinese medium of instruction, then of course it is mandatory. You need to clear at least HSK level 3 or 4. Chinese proficiency certificate exam is mandatory. But if you are choosing English medium, there is no need of this HSK. It is not mandatory, especially if you are doing PhD or masters or postdoc. It's not mandatory. Research in purpose, it is not mandatory. So of course, these are the opportunities. And last, if you're an engineer, do what you will. develop what you have, be satisfied with yourself. Real masters cannot follow others. Don't concentrate on existing, try to create new things. So good luck. The luck which I believe is something different. So L stands for learning, U stands for understanding. If you start learning so that you can understand the concept, if you start learning and understand the concept so that you can become a confident communicator, if you start learning and understanding concept and you can become a confident communicator, then you will be termed as a knowledgeable person. So thank you very much for the opportunity. As I mentioned, within 1 hour I have completed. If there is any queries, I'm happy to answer if any queries. Thank you very much.
Thank you, Subhash sir. For the participants, if you have any doubts, you can ask directly. Please unmute your mic, or you can send the questions in the chat box.
Any questions in the chat also I'm able to address. I think no questions. Any questions about technologies, about IEEE, about China, something like that, you're feel to ask. No questions?
So I think there is no question, so we move to the Devanshi, please.
Okay, thank you, sir, for an enlightening session that not only deepened our understanding of battery technologies and advanced BMS, but also opened our eyes to career opportunities in China, IEEE funding schemes, and the inspiring way people there are embracing electronic technologies and vehicles. As a token of our appreciation, we are delighted to present you with a virtual memento and certificate.
Thank you very much.
Okay, on behalf of the organizing team, I thank Dr. Subhash for taking the time to take this session. And it was indeed an enlightening and thought-provoking lecture on batteries and battery management technologies. So along with that, he introduced some of the funding opportunities as well as the scholarship which is available in the EV side as well as for the students in the learning side also. So thank you for Subhash sir for this online session. Thank you, sir.
Thank you.
So our next session will start at 5 p.m.
Hello, Dr. Eugene. Hello.
Sir, we can,
Yeah.
sir.
Yeah, already. I think most students are leaving. That's why.
Yeah, I think they are on travel or something.
Yeah.
Okay. So good evening, all. We are moving to the next session that is on bidirectional power control between the battery and the grid. This session is handled by Dr. M. Nandakumar, our Senior Professor of Department of Tripoli, Christ College of Engineering, Irinalakuda. For the welcome you, sir, for the session.
Thank you.
And I invite the student branch volunteer, Ms. Anil, for introducing sir.
So once again, good evening everyone. We will now proceed to session 3 of today's program. And it's my honor to introduce today's distinguished guest, Dr. M. Nandakumar, an eminent academician and researcher in the field of electrical and electronics engineering. Dr. Nandakumar completed his BTech in electrical engineering from Government Engineering College, Thrissur, followed by an MTech in industrial electronics from NIT Surathkal. He was awarded his PhD in power electronics from IIT Madras, specializing in control of grid interactive inverter systems. With a distinguished teaching career spanning nearly 3 decades, he has served as assistant professor, associate professor, professor, and head of department at various government engineering colleges under the Department of Technical Education, Kerala, and retired from Government Engineering College, Thrissur, as professor and head of electrical engineering. He later contributed as professor and HOD at SCMS School of Engineering and Technology, Karikutti, and currently serves as professor of electrical and electronics engineering at Christ College of Engineering, Irinalakuda. Dr. Nandakumar has also held research positions, including Senior Research Officer at the Biomedical Technology Wing of Sri Chitra Institute of Medical Sciences, Trivandrum, and Research Engineer at the Fluid Control Institute, Palakkad. His prolific research includes numerous publications in reputed journals such as IEEE, Elsevier, IndusScience, and IET, covering areas like power electronics, power quality, DC to DC converters, FACS, and custom power devices. His work on partially shaded photovoltaic arrays, active power filters, and advanced control strategies has been widely recognized. He has guided several research scholars, contributed to national and international conferences, and received the Professor M. M. Ghani Award for Best College Teacher under the University of Calicut. With his expertise and lifelong dedication to academics and research, Dr. Nandakumar continues to inspire the next generation of engineers and researchers. We are indeed fortunate to have him with us today to share his expertise. I now warmly welcome Dr. M. Nandakumar to lead today's session.